Hello everyone. In this lesson, we'll delve into a communication protocol widely used in the industrial sector, Modbus TCP, and learn how to implement this communication using the MB client instruction in Siemens PLC. Next, let's learn about the instruction to Modbus TCP communication. The Modbus protocol is a universal language for electronic controllers. Through this protocol, the communication between controllers and controllers with other devices can be realized. It follows a request-response mode and operates in a master-slave communication mode. Modbus supports both serial interfaces and Internet devices. Modbus mainly includes three variants, which are Modbus TCP, Modbus RTU, and Modbus ASK. Next, please answer this question. Which of the following is not a communication mode supported by the Modbus protocol? A. Modbus TCP, B. Modbus RTU, C. Modbus ASK, D. Modbus USB. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is D. Did everyone choose the right answer? Okay, let's continue. The main content of this lesson is the Modbus TCP. With Modbus TCP protocol, controllers can communicate with each other or with other devices through network. The interaction mode of Modbus is a request-response protocol, requiring a client which sends request and a server which processes request and returns response. The typical servers include industrial computer and industrial controllers, etc. The typical client devices include PLC and other devices. When Modbus use Ethernet for transmission, devices are interconnected via network cables and switches. In network applications, there are clients and servers. The client sends requests to server, and the server returns results to the client. The key differences between Modbus TCP and Modbus RTU include: the first is the slave address is not more important, because Modbus TCP can return to slave station through IP address. The second is CRC check is removed. Since checking already exists in TCP IP data packets, CRC check is no longer required. Third, although there is no CRC check, an MBAP handler is added. MBAP handler includes all information necessary to route message to the target device address. Modbus protocol uses 502 serial to perform TCP IP communication. When routers and clients in the entire TCP IP network perform addressing through Modbus TCP, network configuration is required. The IP address indicates the specific location of a device on the network. The subnet mask can reduce the number of routine entries in the routine table, and improve forwarding speed. The default gateway can send a message to other networks to find the target host. Digital types of the Modbus protocol. The Modbus protocol defines 4 accessible data types, namely coils, discrete inputs, registers, and holding registers. Discrete inputs and coils only support access in bit mode, while input registers and holding registers only support address in word mode. Discrete input and input registers only support read access, while coils and holding registers support both read and write operations. Address range of the Modbus protocol. The address range stores different types of data through numberings. The numberings of the Modbus address range starts from 1. Theoretically, each type of data supports a maximum of 536 elements. However, since 536 is a relatively large value, and such a large storage area is generally not required in practical applications. PLC manufacturers commonly use an address range with 10000. The address ranges corresponding to each data type of the Modbus protocol are shown in a table. The address range of coils is 0001 to 09999. For discrete inputs is 1001 to 19999. For input registers is 30001 39999, and for holding registers is 4001 to 4999. Next, please answer this question. In the Modbus protocol, what is the address range for holding registers? A. 0001 to 09999. B. 10001 to 19999. C. 30001 to 39999. D. 40001 to 49999. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is D. Did everyone choose the right answer? Everybody, after learning the theoretical knowledge related to Modbus TCP/IP, I believe you have gained a preliminary understanding of this protocol. Next, we'll learn about the Siemens PLC instruction MB client corresponding to this protocol in practical applications. When programming the S7-1200 at the Modbus TCP client, the MB client instruction block needs to be called on the S7-1002 client side. This instruction block mainly handles tasks such as establishing TCP connections between client and the server, sending command message, receiving responses, and controlling server disconnection. The description of each pin of this instruction is shown in the table. IQ indicates a communication request with the server, which is valid on a rising edge. Through the disconnect parameter, you can control the establishment and termination of the connection with the Modbus TCP server. 0 means establish connection. 1 means terminate connection. MB mode selects the Modbus request mode. MB data address selects the Modbus request mode. MB data line is the data length, the number of bits or words for data address. MB data PTR is a pointer to the Modbus data register. Connect is a pointer to the connection description structure. It uses the TCON IPv4 data type. Next, please answer this question. Which using the MB client instruction of the Siemens S7 1200 PLC? Which of the following parameters is used to control the connection state with the Modbus TCP server? A. IQ. B. Disconnect. C. MB mode. D. Connect. I will give you 5 seconds to think, and we will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's continue. Here we mainly list 2 of the relationships among MB mode, MB data address, MB data line, and Modbus TCP function codes as shown in the table. Taking the application of reading Finacle robot DO signals and writing Finacle DI signals as an example, the parameters of each pin of the MB client instruction are shown in the figure. Next, we will focus on learning about the pointer to the connection description structure pointed by the instruction pin. Connect. This pointer uses the TCON IPv4 data type, and the function description and the specific settings of the parameters are shown in the figure. Interface ID is the communication interface identifier of the PLC, and the connection ID can be set by yourself. Connection type 11 is TCP and 19 is UDP. For active passive connection, 1 is active connection. IP4 address. Fill in the IP address of the robot side. The default communication port number on the robot side is 502. Next, please answer 2 questions. Question 1. When configuring the connection decryption structure pointed by the connect pin of the MB client instruction, which data type should be used? A. TCON IPv6. B. TCON IPv4. C. TCON UDP. D. TCON serial. I will give you 5 seconds to think, and I will show the answer after 5 seconds. The answer to this question is B. Question 2. Which of the following ports is used for communication by the Modbus TCP protocol? A. 21. B. 80, C. 502, D. 23. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is C. Did you answer both questions correctly? Finally, let's summarize the main content of this lesson. In this lesson, we learned about the Modbus TCP protocol and the MB client instruction of Siemens PLC, understood the communication principles and address ranges of Modbus TCP, and mastered the parameter configuration of the MB client instruction, which will lay the foundation for subsequent practical operations. For specific practical applications, please continue to watch the practical operation videos of the relevant section in this chapter. That's all for this lesson. See you next time.